Hi, the purpose of this video is to help you answer the question on the back of the performance assessment. So in this word problem, we're actually asked to determine how far the boat is from the shore. So what they want is this distance right here. That's what we're asked to determine. We're going to kind of solve a couple triangles by using the law of sines. And then first, we're going to focus on this top triangle here. We're going to use the law of sines to determine the length of this side right here. And we're also going to fill in all of our missing angle measurements and then ultimately figure out this triangle down here and use the law of sines again to determine this length. Okay, so let me clean this up a little. Here we go. Going to first determine every missing angle measurement by using the fact that angles on a straight line add up to 180 degrees. So this is a straight line right here, which makes this missing angle 80 degrees. This is a straight line right here, which makes this missing angle 70 degrees, because 70 plus 110 is 180. 80 plus 100 is 180. We can now use the fact that angles in a triangle add up to 180. 70 plus 100 is 170, which makes this little missing angle 10. And 80 plus 90 is 170, which makes this little angle here 10. All right. There are many ways you can do this problem. I'm going to use the law of sines twice. So let's just focus on this red triangle for a moment. We have a known angle side pair. We know that this is 550 feet and this angle is 10 degrees. So I'm going to begin by setting up my proportion with that information. The sine of 10 degrees is proportional to side 550. This ratio should be equal to this ratio, the sine of 70 degrees over this missing side here, which we'll call that side x. So this is going to determine the length of this yellow side. And I'm going to go ahead and use my calculator to solve this proportion. This times this divided by this equals this. 550 multiplied by sine of 70 divided by sine of 10. So now I have the length of this. It's 2,976.3 feet. So now we're going to focus on the bottom triangle, and we're going to use the law of sines again to determine that dotted line length. We have a known angle side pair now because we know this angle is 90, and we know the opposing side length is 2,976.3. So I'm going to set up my proportion with that known information. Sine of 90 degrees over 2,976.3 feet is proportional to sine of 80 degrees. We'll call this here, this distance from the boat to the shore, we'll call that S over S. All right, so to solve for the distance to the shoreline, again, we're just going to cross multiply and divide. This times this divided by this equals this. So 2,976.3 feet multiplied by the sine of 80 degrees divided by the sine of 90 degrees, and that gives us the distance to the shoreline. There are more than one way to do this problem. I think somebody in your class did it using law of cosines, but I think it's more simple to just do it in two parts like this. All right, let me know if you have any other questions. You can send me an email.